For today's quiz, we've got this old sturdy bottle. It's nice and thick. It's got a little bit of water in it, just a few drops. What we're going to do is we're going to put this in the microwave oven. And then, once it's heated up sufficiently, we're just going to put one of these little, I think they're called grape tomatoes or cherry tomatoes, and we'll just find one that fits on there rather nicely. All we want to know is what's going to happen over time. Here's what your quiz looks like today. It says a glass bottle has just a few drops of water at the bottom when it is heated. A cherry tomato is then placed on the top of the bottle. What happens? As always, mark your answers to the best of your ability and list your confidence. Typical student responses are, first of all, going to ask, does the tomato seal with the top? And the answer is yes. We'll make sure it seals. In fact, we might even have to put a little bit of oil around that tomato just to make sure that it seals properly there. And I have to make sure I have one that's large enough. But our answers and responses are, first of all, if the air is now hot inside, it's going to pop the tomato off. Others will say nothing's going to happen because eventually the tomato and the bottle and the contents are going to be about the same temperature. And some will say, no, as it cools down, the molecules are going to end up going slower and they're going to take up less volume, and it's going to create a vacuum and it's going to suck this in. So those are the typical responses that we get. Of the three responses that we were given, the third makes the most sense. Look, if I have hot water in here, and actually we're going to play a little trick here, we're going to make a little bit of steam, most likely. As the molecules are inside here and expanding, they're going faster on average than the molecules out here. Now, we're not going to worry too much about the bottle being hot, and that's why I'm going to use a microwave. I'll run it down, put it in the microwave. Microwaves are wonderful at heating up water molecules, not so much with the glass. So that's what we're hoping. As those molecules are at an excited velocity, they're going to end up expanding. Well, once we end up putting this on as kind of like a cork, well, now we have a sealed container. Look, the rest of the air molecules in the atmosphere around us are still doing their normal thing. They're bouncing around and they have an average temperature of whatever room temperature is. But as the bottle and the contents inside cool, they're going to end up having less and less high velocity hits, which means they're going to take up less room. That third suggestion by the student is it creating a vacuum. Well, I don't know if we should really say it's creating a vacuum. More, we should say, well, the pressure is going to end up decreasing here. And because I have more pressure, more hits on the top of this tomato, we're going to expect that it's going to end up being pushed down because, yes, I still have some molecules as they're cooling down. They're still hitting the bottom of the tomato, but not as many hits, and certainly not as with as much force. So we're going to expect we're going to have higher pressure on one side, lower on the other, and we're thinking that this tomato could get sucked in. Well, let's see what happens. I'm going to go heat this up. Well, the bottle's a little hotter than I thought it was going to be. And now I'm going to put this tomato on here, and I'm going to stick it in there so it seals. And I did put just the slightest bit of oil on it. It had some water on it, but it wasn't sufficiently staying on. It was kind of bubbling off there. So we're just going to let this cool. Let me take this off and give this a second. Wiping off my hands. In the interest of time, maybe we'll try to cool this bottle down a little bit because it's hotter than I thought it would be. I'll spray it with a little bit of water. That did it, and that absolutely shows that the pressure was higher on the top and the bottom. Let me wipe some of this up real quick. All right, now that I got the water off the electrical equipment that I accidentally sprayed, let's talk about a real world example of this. Look, if you buy containers, they'll have a little, especially if they're a glass container. This wouldn't work as well for plastic or anything like that. But what they'll often do is they'll take, let's say you're out in your garden and you want to can some things or bottle them. You're going to end up heating them up and essentially killing any bacteria. And as it cools inside, those molecules slow down. It's going to end up pulling the cap down. So whenever you take a cap off, you'll hear air trying to rush in. And if you don't hear that, or if this little tab is not down, we call it a safety tab, then you know that your seal has been compromised and you probably shouldn't eat that particular foodstuff. So, all right, pretty neat example of kinetic molecular theory. So that's our quiz for today.